Hi guys, in today's video we're going to take a look at what is the Maxwell-Boltzmann curve, the Maxwell-Boltzmann curve looking at the influence of temperature and catalysts, an exam style question, and finally a summary.
So what is the Boltzmann curve? Well, the Boltzmann curve shows us the distribution of molecular energies in a gas at a constant temperature. So what we see is that some molecules move fast and have a high energy, as shown here. But some molecules also move slow and have a low energy, as shown here. But the majority of the molecules we find have an average energy. So here we have our Boltzmann curve. On the x-axis we have the kinetic energy, and on the y-axis we have the number of particles with that specific kinetic energy. And there are a number of features of the curve that we're going to have a look at. First of all, the area under the curve is equal to the total number of molecules in the sample. Second, the curve starts at the origin. There are no molecules in the system with zero energy. And thirdly, only molecules with a greater energy than the activation energy can react. And we can mark the activation energy onto our graph where it applies. So now we've had a brief introduction to the Maxwell-Boltzmann curve. Let's have a look at it in specific relation to increasing the temperature of a reaction. Well, we know that at higher temperatures, the kinetic energy of the molecules increases. So what we'll see is that from our original curve, we have a slightly different curve. The peak moves to the right and it becomes a lower peak. So here, the curve labelled T2 is symbolising a curve at a higher temperature. Now it's important to notice that the area under the curve remains the same. The number of molecules in the system is exactly the same, but there are some slight differences. So what are they and what's happening? Well, the molecules are moving faster as they have more kinetic energy at a higher temperature. So we see a greater proportion of the molecules have an energy greater than the activation energy. So if we take a look at our graph, we can see that the activation energy is marked on here as EA. And we can see the proportion of molecules with energy greater than the activation energy at T1, the lower temperature, is shown in dark green, whereas the proportion of molecules with energy greater than the activation energy at T2 is shown as the area that's green and the area that's grey. So that's that total area altogether. We can see it's increased. So this is because there are more successful collisions occur in a given length of time, and therefore the rate of reaction will increase. So now I've had a look at the curve in relation to increasing the temperature. Let's have a look at the curve in relation to the presence of a catalyst. Well, we know that the catalysts lower the activation energy of a reaction.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific A-level chemistry videos, just click the Snap Provide smiley face. Join me today and together let's make A-level chemistry a walk in the park.